Before I start on conditional statements, you got any queries for me, Ratnakar?
No, Ravi. I think I'm good with whatever we discussed.
Very good. Okay. I'm sure you have at least a little idea on what are these conditional statements in general, right?
Yes, yes.
For the due course of time, we might have to do certain operations if certain conditions are met. For example, if I take an example from this add2.sh, here we are basically adding only two numbers. If you look at this, right? So when I run this program add2.sh, and when I say 10 and 20, I'm getting the output. Okay. Export path is equals to $path colon dot add2.sh 10 20. Not only that, even when I give three arguments, I'm getting the output. When I run with like only one argument also, I'm getting some output. So it's not right. If I am running a program in a right manner, I should get the output. If I am not running a program in a right manner, I should be notified back saying, buddy, that's not how you run a program, especially this program. So you should run it so and so way. For example, let me modify it. Let me write a program for addition of three numbers. Bin bash. I say number one equal to $1, number two equal to $2, number three equal to $3. Total is equal to expr of number one plus number two plus number three. Echo sum of number is total. And this is basically the addition of three numbers. So what I'm going to add here is a little if condition, something like this. If number of arguments not equal to 3. I'll cover in detail what is this if syntax and all that. I'm just writing it here for till showcase. That's it. I'm saying echo usage $0 number one, number two, number three. Echo, for example, add 3.sh 10, 20, 30. Exit 1. This is all we know from our previous exercises, but the lines that I have added here is these 5 extra lines. What these extra lines means is if $hash. What is this $hash from positional parameter signifies is number of arguments is not equal to 3. Number of given positional arguments are not equal to 3. Since we are adding 3 numbers, if they are not 3, I am displaying these 3 echo statements. So how it looks like when we run is, if I clear it, change mode, user plus x, 3.sh. Okay, so what was the last thing you heard from me?
Yeah, I think it was a slide before this one. No, I think the screen you're showing on the.
This is showing. So
Yeah,
basically,
right.
I
But
wrote here a program to add three numbers. Like number one is equal to $1, number two equals to $2, number three equals to $3. Then I'm adding these numbers as expr number one plus number two plus number three. And I'm saying equal sum of three numbers is so and so. But what we
okay,
are doing at the top is I have added 5 little lines here that change the direction of the program execution. If $hash is number of arguments is not equal to 3, we are doing some little magic here. So what this little magic does here is it stops the execution if the given number of arguments are not as per the program expectations. But what used to happen in previous examples is in add2.sh, even though we pass wrong arguments, the program flow will continue, right?
all right, got it.
Exit statement by adding such kind of a conditional statement will stop the execution if it is not meeting the program expectations of three arguments. Okay, before I go in detail about what is this if does and all that, let me show you this add3.sh. If I run add3.sh like this, it will immediately throw a usage to me. Like every program should have a usage, right? You know, if we are
Right,
entering into any new environment, it looks good to have some comments in a program. It looks very good to have some documentation on how to run a program or a shell script, right? So when I run this add3.sh, since I am not passing the three arguments, I am immediately getting a message that says usage. Add3.sh number 1, number 2 and number 3. For
yes,
example, add3.sh 10, 20 and 30. Okay.
right.
Now, what kind of little things we can do with these conditional statements? One such conditional statement is of course if, and another conditional statements we look at today is a case statement. So let me first walk you through this if condition syntax. This is of
Yes,
course true. We need to take different courses of action. If construction allows us to do such conditions. The basic if syntax is, it's a little looks little awkward, but once we start getting used to it, it is okay. If has to end with fi, so then the if block conditions has to be inside then then. Then the next one is if then else syntax. So if certain conditions are met, then execute these commands or conditions, whatever it is inside, else execute something else. Okay, like if number of arguments are 3, do this, else do so and so. If I modify this my if block here, I add 3.sh, I remove it here, I add it like this. Yes. So if number of arguments are not equal to 3, exit. If number of arguments are 3, exit with 0. When I come out of this and when I run this program, and if I print the return status, it is 1.
okay,
If I print the return status, my return status is 0.
okay, got it.
Okay. Now let's look at few examples in this if statement. Okay. If you look at my first example here called usercheck.sh, this script basically checks for a given user whether the user exists in etc password or not. So can you take a minute to please go through from this line to this line?
Yeah, sure. Yeah, I went through it.
It makes sense, right?
The only thing I had a question is like, uh, if grep you use this sign before the user.
Okay. This cap symbol, right?
Yeah.
Okay. Heard of that cap symbol or a dollar symbol before?
Uh, I don't remember using this one. I mean, like generally for a wildcard, I would use
Star.
a star, but yeah. Okay. I heard about this symbol. Sorry. I mean, in VI you do that to change the first word of the line.
Exactly. So when I use this cap symbol, what I'm explicitly saying is check for this user one colon at the starting of a line. So before you write the shell script, we need to understand how the users were built in etc password. So if I do cat, if I clear this, and if I do cat etc password, this is how a record exists for each user, right? If I take it for db to inst1, this is the username
Okay.
and this is
Okay.
encrypted password. This is the user ID and this is the group ID, and there is a comment field here, and this is the home directory, and this is the default shell. So 1, 2, 3, 4, 5, 6, 7. Total 7 fields are there. In that we are checking for the first field. Okay. We are checking for the first field which has to immediately followed by colon.
Okay. Got it. Yeah.
Why we are checking for colon here is even when you give db to inst it matches. We want to exactly match with the first word. We want to exactly match with this. So
Okay. Right. Yes.
otherwise if someone passes only db to inst, it still matches here, so you get a result. No, I want exactly matches with db to inst1. Okay.
Okay. Yes.
And this is a quick script that says whether a given user exists in a system or not.
Sure. Yeah.
When I say db to inst1, it says that written code blah 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 user exists on the system. When I say this only in inst, the written code is 1. It does not exist on the system.
Okay. Sure.
Just playing around grep statement here.
Yeah.
Okay. Here I'm using certain command in a if condition. The output from this grep command, the return code of this grep command, I am using it here. If this condition is successful, then I am doing this, else I am doing this. Here I am saying if the Unix command is successful, right? So I'm basically playing around here on the return code of a Unix command. Like this, what else I can use it along with this in this little space is I can use various primary expressions, such as I can open a little left bracket and close a left bracket. In middle I say -f and I pass a file name that says that whether this file exists or not, and I can check whether the file exists and I have a read permission or not. I can check I have a write permission, and I can write -z and a string name to say whether the string length is 0 or not. I can compare two strings. Little expressions I can use along with if here. If
Oh, yes. Yeah,
yeah,
I think I did use the file.
you might have come across this -f, right? Okay.
Yes, yeah.
Along with these little primary expressions, I can also use some comparison operations like argument 1 operation and argument 2, like x greater than 5. So here OP, I can use any one of these English characters. -EQ stands for equal, -NE stands for not equal, less than or equal, greater than or greater than or equal. The left side and right side has to lead to a number. So I say x hyphen like number of arguments not equal to argument 2. And similarly I can combine multiple expressions here. So I can just simply say if negation of expression, it exactly works in opposite way. I can say expression 1 and -a and expression 2, and I can say expression 1 or expression 2, like x greater than 5 and y less than 6, or x greater than 5 or y less than 6. I can combine various expressions. Since I am using these expressions in middle and these are not commands, I have to place them in left bracket and right bracket. Basically this left
Okay.
bracket works and right bracket works as a test condition. Let's look at a little example. In this example I'll be using one primary expression with -f. So this script basically checks for var messages, file whether exists or
Okay.
not. So what I'll be doing here is if same then fi, and in this left bracket and right bracket I'm saying that -f whether the file exists. Have you come across the usage of these
Yeah.
primary expressions? Okay, before, okay. So then I'll move to the next example.
Yeah, sure. I have used this one for sure.
So here is a command line addition. What we are basically doing is before I add two numbers here, number 1 and number 2, I'm checking that $hash. Remember this hyphen not equal to, when you use this string in middle, left side and right side has to lead to a number. $hash is
Okay.
that is a number, and right side is a 2, that is a number. So if left side and right side are number, in middle you use string.
Okay.
Okay. So here just like 4 little lines that says if number of arguments are not 2 in addition of 2 numbers, it will throw a usage.
Yeah, yeah.
So here is another little example. So just give me a quick minute in the meantime, and can you please glance it from top to bottom.
Yeah, sure.
Okay, can you see this the if statement, the first if statement, what is the difference we are doing here?
Yeah, I think earlier we discussed the equals as EQ, but I think here you're trying to use the actual equal sign.
Yeah,
I think
this actually works as a string comparison. Okay, here since this topic came, let me show you a little example. Okay, vi s.sh. string 1 equal to 0 1, string 2 equal to 1. When I say if string 1 equal to $string 2, then F5. So
Is the double quotes necessary for any comparison here?
it's not really needed, but it's good to have them. It's not really needed, yeah. Okay. Let me not complicate it. What happened? Okay. In a real numeric terms, 0 1 is equal to 1. Right. Whether I say 0 1 or a 1, it's the same thing to me with respect to numbers. But let me see how this hyphen equal and equal equal treats it. Okay.
Okay. I think the first one should match word to word. Second one is an actual comparison.
Okay.
If I remember it correctly. One or two are same. Okay.
Well, okay. I think I need to modify it.
Okay.
You see the output that is coming in?
Yes.
The first one does not have, it's opposite to what you mentioned.
Okay, fine.
It actually compares position by position. So 0 1 is not equal to 1 in string word. Both are two different strings. But when you use hyphen equal, 0 1 is equals to 1.
Okay.
So when I do s.sh, let me modify it a bit. Zero 1 and 0 1, you get both strings are same. You get only with hyphen equal. String 1 and string 2 are same.
Okay.
Generally, we use equal equal only to compare strings, alphabetical strings only. So to compare numbers, we always use hyphen equal or hyphen not equal. So here, it does not matter as long as you know what you are doing. You can use this equal equal to compare numbers as well. If number of arguments is equals to 2, that is true, and the negation. That means if number of arguments are not equal to 2, then we display this usage. At the bottom, we are using this primary expression of hyphen LT. I mean, two different things in the same example. So So the example is not really, what we are doing is not really important, but I just wanted to highlight this.
Yeah, sure.
Okay. So here in this example 5, we are doing a string comparison with equal and not equal symbols. So there are two ways, right? If I want to execute a Unix operating system command, I can put it in a single quotes. So I should have written here.
Oh, okay, got it.
Either I can use dollar in brackets or single quotes.
Okay, sure. Yeah, I remember this.
You are good with this example?
Yes.
Okay. So what I have in my next slide is, so far we have been using like if then fi and if then fi and else if. There is something called advanced if concept as well, that we can nest if loops to whatever the length we want. We can use nested ifs and nested ifs and nested ifs to whatever the length we want. If then, if you want else fi, again in else you can use this if then fi statements like this. And if you are little if you want to save a little word or so, a line or so, you can say else if as a single elif.
Oh, okay.
But I don't recommend this elif statement because this is a confusing thing with respect to maintenance. So,
Okay. Got it.
nowadays
Yeah.
we have enough processing power. Back in old days, people say that if someone wrote a program in 10 lines and if someone wrote the same program in 5 lines is the best one. People think that way because number of program instructions. Now we are more worried about maintenance of things than someone finishing it up faster and leaving. So this is much user friendly.
Yeah, sure. Right.
And here I have one simple example with this. Here I haven't used here simple quotations, so this is okay. But it's generally preferable to use the single quotation. I mean double quotation. Sorry.
Yeah, yeah, that's what, yeah, I saw a few instances both ways. I was trying to make sure it's an aesthetic.
Yeah, no, it's okay. So here is an example with elif. The same example. It looks very clumsy. Okay. Let me ask you this. Have you ever noticed the difference between single quote and double quotes putting around echo statement? I say here echo count is greater than 100. What happens if I put single quote here?
Uh,
Let me show you with example. vi codes.sh
I'm assuming it displays the single quote also.
echo hello world echo hello world single quote. So when I run this codes.sh, it displays the both. You are right. But when the difference comes in is when we are trying to display variables in it. For example,
Okay, okay.
if I declare a variable here called let's say sum, let's not call it's not complicated, look for semantics. Saying sum, the sum is $sum, right? When I do quotes.sh, and when I say quotes.sh, here is a little difference.
Okay, I see.
Whatever the replacements, dollar values will be substituted inside the double quotes, but not under single quotations. Why? Because it's not why, because that's why double quotes are called weaker quotes and single quotes are called stronger quotes. Stronger in the sense they won't allow any substitutions in it.
Okay.
These are strong quotes and these are weak quotes.
Okay.
It's a little difference, but I'm not sure I've ever noticed it before.
Yeah, I really did not. Double quote was what I was using, so I didn't really
Okay.
play around with it.
Well, this is a nice example to the little difference. And coming back to our if statement, if you are really worried about using this left bracket and right bracket, there is a command called test. You can just simply write test to replace left bracket and right bracket.
Okay.
It simplifies the stuff. What happens is if you use left bracket, you have to use space on the left side and a space on the right side. And here also a space here, and it doesn't matter if you keep space right side. So these are the general syntax errors we get. We immediately start there has to be space. But if you just, it doesn't matter. It's up to you whether you want to use test or you just have to use this left and right brackets. This is just an alternative to if statement. If for that left brackets. So that's all about if I have. But however, going forward, we have in real-time scenarios where we use if. The basic purpose of if is to decide the program execution depending upon the certain conditions. Like if I quickly recap, in the first if example, what I have given is I have given a command here. Based upon the command output, we are taking a respective action later. So instead of these commands, we can also use primary expressions. Where is primary expressions, we have to keep it in the inside left bracket and right bracket. And we can check for whether file expressions, string comparisons, and numerical comparison, and multiple combination of expressions such as negation, and or. And also we can use advanced if we have to loop if we some certain 3 or 4 levels deeper, we can do that. And we looked at replacement of this left bracket and right bracket with the test condition. And we also looked at on the slide line that difference between single quotes and double quotes.
Yes.
The next example in conditional statement we have is a case statement. Like if is not a loop, right? If is only executed once, right? If is just a statement, say statement will be executed only once unless you loop it on the top. Similarly, case is also a statement, it will be executed only once. Here is a syntax. Case, it will end with exact opposite wording, ESAC. If a specific variable name, value here, in pattern 1, pattern 2, if it is in a pattern 1, the following commands will be executed till it reaches this double semicolon. Pattern 2, this commands will be executed till this double semicolon. The default condition is star in brackets. So if none of the patterns match the above, whatever you write in this default will be executed. Here I have a quick example. Here I'm assigning platform is equals to /bin/uname. Basically I'm running the uname command. So I'll get here whether Linux or AX or Sun Solaris or CentOS, whatever the platform name, I'll get it right. Then what I am doing is case if platform name in Linux, I am assigning the host by running this bin hostname command. Whereas if platform is SunOS or HP Unix or AX, I am assigning the host value to host by running this user bin hostname. These kind of statements we use if you are writing a single shell script that you would like to run it on all your platforms. Generally, if you are customizing a shell script to work in all environments. For example, if you have DBA servers running on Linux, AIX both at the same time, you cannot write a separate script, right? The script should be in a position to run it for all, single script. So it's such kind of a platform differences you can avoid. Here is one example you can use it. So if it matches the Linux, it finds this double semicolon, whatever you write will be executed. And basically it's a combination of multiple if statements. If platform is Linux, do this. Else if platform is SunOS, do this, and by default do this. Nothing else. It is a bunch of statements given another name as a case.
Yeah, sure.
And here is another example.
So the last one is just anything you're saying, right? The star.
Yeah. If none of these matches for the choice, remember this case will be executed only once unless someone repeats this in a loop. So I enter a choice here. If I enter a choice here 5, it comes here and checks 1 is not equal to 5, 2 is not equal to 5, 3 is not equal to 5, 4 is not equal to 5. So then immediately it finds this default one. Whatever you write it in a default one, it will execute. I mean, if none of the patterns match the above, this will be executed. Okay, if I quickly copy it. So it's asking me to enter the choice. If I say 3, what are the statements I have written at 3 pattern called, and all the commands will be executed till I have this double semicolon.
Okay.
Generally, where you can use this case statement is if you are trying to customize your day-to-day activities. So you can write a high-level shell script, that when you call it displays options like this. Like if you want to find out blocked sections, enter 1. If you want to find out deadlock sections right now, enter 2. If you want to find out table spaces more than like 90%, enter option 3. If you want to find out the instance status, enter 4. If you want to make your day-to-day DBA administration or tasks command free or SQL free, you can automate such things in a single SQL like this. In the background, what happens is To check the instance status, for example, in DB2, you grep for DB2 system. When I enter 4 here, you basically go ahead and do all that logic in the single shell script. So instead of you assuming. So using
Okay.
DB2 top, you can find out the top CPU consuming session. You can do such stuff here. You see what I'm trying to say?
Sure.
A
Yeah, yeah,
single,
got it. Makes
yeah, you
sense.
just run this executable, and if you have like 20-30 DPS, all will run the same thing. They don't have to remember it.
Yes, makes sense.
It's not. It's first time. It's fun to learn something new. Every time repeatedly doing the tedious task is not fun. So you just automate it here. At least the top 10 things that you can automate. People call the shell script and enter it. They get the stuff done.
Right, right, exactly. Like something like a health check, maybe.
Yeah, health check. Right, you are right. So every day we check the production's health check and block sessions. What is the CPU usage? What is this thing and what is that thing? A bunch of standard 7 or 8 stuff.
Right.
Then just select it and it writes into an output file. From that output file, you can automatically make sure you receive an email to enter your DBA root instead of you copying it from here and putting in an email and sending it an email. Yeah.
Yes.
So here is another example for clear statement. I mean, nothing fancy we are doing. Instead of a single command, so I have added like multiple commands here.
Okay, right. Yeah, got it.
Here is an enhanced cleanup script. What we are doing is we are taking in var log directory. Root user ID has 0 value. Only with user ID you have root privileges. So lines equal to 50. So on, so is 86, is 87. Here we are checking that if you want to clean up something under var log, you should be a root. So if user ID, UID, the UID of a current user that is running this will be in a UID. You don't have to worry about it. When you say echo $UID, your current user ID is 501. Because when you grab it from DB to NST1, this is your user ID. When you grab for root,
Okay.
your user ID is 0. So I'm here basically checking whether your user ID matches 0. If not, you are not a root and you are exiting with a written code here. If -n $1, if first argument exists, what do we do with first argument? Like number of lines to clean up. In a messages file, how many lines you want to clean up. It's not that entire complete messages file you want to clean up. I think, here this example says number of lines you are picking up from command line. If no number of lines given by default, you are using it for 50 lines. Basically, we are doing the same thing using case statement here. If case, first argument, $1 in, if there is nothing submitted as a $1, lines equal to 50. Okay. If something is given, but 0 to minus 9 in the sense it has to be a number. 0 to -9 star in the sense it has to be a number. If we are given anything other than number because exclamation present here, we are saying that usage is lines to clean up. Buddy, you should enter here number, not non-number enter. First we are checking whether user is entering the first character. first argument, command line parameter. If command line parameter is there, we are checking whether it is integer or non-integer. We are checking if it is non-integer, we are displaying the usage. Otherwise, we are just storing these lines in a lines field. The same thing, using if statement, we can do the same thing, but here in a case statement, we are checking that whether the first argument, this might fail here, right? If the first argument exists, but if the first argument is non-integer, right? So here we are making sure that the argument entered is an integer one. Then if present working directory not equal to log dir, not in var log, then you're trying to do cd to log underscore dir. And next we are checking that whether the cd command is successful or not. If your present working directory after shifting to log dir is not equal to log underscore dir, that means not in var log, then something is not right. Now here what we are doing is we are using a tail syntax, tail -n, 50 lines from messages writing to a messages.temp. Basically we are moving those 50 lines back to messages files. That means even if your messages file has more than 1000 lines, the last 50 lines you are writing it to a temp. Now you are moving those last 50 lines back to messages in the sense rest of the 950 lines will go away.
Okay.
And we are not worrying about wtemp, we are just cleaning up a wtemp directory. Here we should have done one more thing is before we actually move like 50 lines or 100 lines, whatever the line number that user gives, we need to first check how many number of lines exist in messages. What if I give 1000 but message has only 50 lines in it, right?
Okay.
Here is the one I was talking about. When I say nl etc password, I get 33 lines, right? When I say tail -n, number of lines is 10 from etc password, I get the last 10 lines. What if I say here 100?
It should list all 33.
It should list all 33. We should have added this check here, but I think this is itself is a little complicated script. I mean, it's unnecessary to run this extra line, right? If number of lines in these messages files are not greater than the given input. I mean, there is always a simpler way of doing things. There is always a little complicated way of doing things. I mean, if you want to check all ifs, then and buts, program would. There is nothing fancy we are doing it here. We are. I should have simply checked for root user ID, and I have just used the alternative way. So if the first argument is present, then if first argument is present and the first argument is non-numeric, then we are exiting. Then we are going to log dir, and then again every command can fail, right? Even the cd itself can fail, even the move itself can fail, the tail itself can fail. So ideally you have to check the if condition and each and every after every command, the return status. But once in a while we take it light for the simplest like tail, move and cat command. We don't check the command return status. Ideally cd should also work because you logged in as a root, there won't be any problem. But like this you can complicate the things by adding many one after another. Yes.
So I have a question, like in real time, like regarding the checks, right? So for every, say, DB2 in this case, would you recommend using a check, whatever we do in the script? Or how would you handle that, like in a real time? Like, I mean, for example, first thing we may have to check is instance is up or running.
Right.
That you can connect to the DB, and so on. Like there are at least few checks that you have to do for any script to work. So recommend, like, say, doing that check in the script itself, or is there any other way you would do, like, write a subscript or something like that and call that to do that validation to keep the actual script simpler?
Yeah, I am a great fan of functions, as in so that
Okay.
it simplifies the job, and we can use the code going forward if there is a need. But for simplest
Okay,
thing,
sure.
functions is a complicated thing. If you are just checking the instance status, ES-EF grep for DB260, right?
Right.
Writing it in a functions and complicating the things is not advisable. But on a huge scale, every program, every shell script we write that monitors something has to send an email alert, right?
Correct.
The
Right.
email alert should be part of a separate function, and the email block should be common across all these shell scripts.
Okay, got it.
Such kind of a things you can automate. If you just checking the instance, I don't think you use in any other script other than like few scripts before you connect into table spaces and getting the data. So it's up to you. If you think there is a need that we are repeating it in more than like 3 or 4 times, okay, use it functions. Like email block has to be there in each and every shell script.
Okay, sure, got it.
Yeah. And again, whether we write the code using if and else, we check the previous command's return status. Again, it depends upon. If I am just taking the cat command, if I'm just doing the cd command, ls command, I don't do return status checks. But after grep, I might check that. But after connecting to a database, I might check that. You see, it depends upon the command we are using.
Yeah.
After diff, I might check that. Diff command, the purpose itself is. If the return status from that command makes any sense, then I use it. Like copying from one location to other location. I check after the copy because the copy might fail because destination does not have enough space.
Right.
Yep. The extract zip file might fail, unzip might fail because the destination does not have enough space. So if there are any negative consequences, I'll check that. But ls, I don't think any complications running ls command. So,
True.
but whenever you do something, place comments like this. You are running as a root, of course, and these commands and why you are using this. I should have added something here for case statement to make sense. Okay. Did I email you these already?
Uh, no, I think I got the two videos that we discussed.
Oh, not the PPTs.
No.